Okay, so P6.6, gas pressure and temperature. And in order to understand gas pressure, the first thing we need to do is we need to be able to imagine a box. And inside my box, I've got particles. And these particles are moving around randomly. And the key thing is randomly. You can't, it's one of the first things you've got to assume is that they move random. Okay? Has to be caused by, and it's random impacts. Okay? So their movement causes random impact. And the reason why that's important is because the pressure on this box is caused by these particles hitting it. So things that you can do to increase that pressure is one, if you increase temperature, then particles move faster. So if you increase temperature, then particles move faster. And what that does is that has two effects. Effect part A is, that means there's more impacts. And effect part B is more energy per impact. Okay, so increasing the temperature has two effects. It means that there's more impacts because they're moving around faster, then they hit the side more often, and when they do hit the side, they're moving faster, so they transfer more energy to the cell, to the container. That's the first one, increased temperature. Second one is if you make the container smaller, because they hit the side more often. Okay, so a smaller container will mean that they hit the sides more often. And then third and finally, the third thing that you can do is increase more is have more of these gas particles. So more particles means more collisions. Okay, so the more of these I have, the more times they're going to hit the side. Now this random movement of particles was first observed by a biologist called Brown, who discovered something called Brownian motion. And what he noticed was he was looking at particles of pollen, he was looking at individual bits of pollen floating in water. And what he noticed that his bits of pollen were jiggling randomly, and he couldn't explain why they were jiggling. So even if he stopped them as much as he couldn't stop them from jiggling completely. They'd still jiggle a little, and he couldn't figure out why they were jiggling. And that took somebody called Einstein to come along to describe the effect and to explain Brownian motion. And what Einstein said if you've got your piece of pollen here and it is constantly being bombarded by particles that are so small you can't see them, but the pollen is so light that these particles can move it a little bit. So each random hit on the side of the pollen would cause the pollen to jiggle a little bit, and then it would get hit by another particle, which would cause it to jiggle in the opposite direction. So what Einstein said was, he said that Brownian motion was caused by the random motion of particles. So he's saying that particles moving randomly and hitting the pollen would cause this jiggling effect. So that was the evidence for what Dr. Brown had noticed.